Alright guys, so next to the last lesson here, 7.5, proportions and variation. So ratios and proportions, this goes back, I don't know, probably 5th grade math. A ratio is a quotient of two numbers, and a proportion, we write a ratio, you can write a ratio as A to B, A dot dot B, or A over B. Now that we're all big and grown up, this is the way we usually write a ratio. A proportion is a statement that two ratios are equal. Again, I don't really know what more to say. We've talked about cross multiplication, the butterfly method here. That's how you prove that two ratios are equal and they are cross products. So let's look at this right here. So suppose you're shopping for a mummified piranha from the Amazon River as a gift for your cousin and see a price tag of 20,000 pesos in a gift shop. If earlier that morning you exchanged 120 American dollars for 237,960 pesos, what is the cost in dollars for this piranha? Okay, if you travel abroad, this is something you kind of need to know. How much is your money worth? Okay, so what you're going to do is we're looking at American dollars versus pesos. And pesos are in Mexico. Okay. So you have 120 American dollars. And that was worth 237,960 pesos. So you feel pretty rich at this point. Okay. And now we want to know how much is a 20,000 peso object. Okay, so we cross multiply 120 times 20,000. It's 2,400,000. So 2,400,000 equals 237,960x. Of course, we're going to divide this, and when we do that, we keep two decimal places because this is money, and it's going to cost you about $10.09 for that mummified piranha. Okay, so easy peasy, right? All right. Go to the next type of problem, capture and recapture method. So marine biologists around the world captured 832 female breeding leatherback turtles and tagged them and released them back into the wild. Several months later, the biologists, I can't read today, take a second sample of 900 female breeding leatherback turtles, of which 7 have been tagged. So use these data to estimate the population of the female leatherback breeding turtles. So we're talking about females that are tagged over just the females total. Okay, so we captured and tagged 832 the first time. We don't know how many there were, okay, that we had. Then we had 7 that were tagged out of the 900 that were captured. So this time we can cross multiply 748, 800 equals 7x. And this would be 106,970, and it goes 1 point something. You can't have a part of a turtle, so you're going to do 972. Okay. All right. Now, let's talk about the different variations in proportions. Okay. So do you have a text messaging plan? We don't anymore. It's just free. Okay, so this is way back in the day. This is how it worked. If you do, then you're familiar with the mathematical notion of direct variation. For an example, if your plan charges you 5 cents per text message, yeah, we used to have to pay per message, Then the equation C equals 0.5t models the relationship between the number of text message T and the cost C. So 50 cents per text. 5 cents. That should be 0.05. That should be 0.05. We're going to fix that. Okay, 0.05. Okay, this is an example of direct variation. Okay, direct variation, as the number of text messages increases or decreases, your cost varies in the same way. So as when one thing goes up, the other thing goes up. Whereas one thing goes down, the other thing goes down. As long as they're working together, that's a direct variation. Okay? Another type of variation is called inverse variation. And that just means that they do the opposite thing. As one quantity increases, the other quantity decreases. So if you're using heating oil or gas, you use more gas for your heat, okay, if it is colder outside. So the lower the temperature, the more heating fuel you use. Okay, so they do the opposite things. Okay, so we say y varies directly as x, and that's directly proportional. And there's always a constant k, the rate at which it's changing. So like that 5 cents a text, or how much it's changing. Okay, the constant k is called the constant of variation or the constant of proportionality. So let's look at this next problem. A beam in the viewing booth for the officials at the Daytona 500 auto race is being replaced. The current beam is 3.5 inches wide, 6 inches deep, and will support a weight of 1,200 pounds. If a replacement beam with the same length is 3 inches wide and 7 inches deep, how much weight can it support? Use the fact, this is the important part, use the fact that the strength of the beam is directly proportional to its width and the square of its depth. Okay, so what that means is, when we start this problem, it says the strength of the beam, we're going to let that be S. When you see is directly proportional to, you put equals K, its width, and the square of its depth. Okay, so that's our formula. So we do the original one to find our K. Okay, and then we'll find the strength. We'll find the strength after for the new one. Okay, so the strength of this one is 1,200 pounds. We don't know K. Our width was 3.5. And the depth is 6. Okay, so if I do 6 squared, that's 36. 36 times 3.5 is 126. So we have 126K. Remember, we divide this over, and that's going to be 9.52. That's our constant. Okay, that's our constant. So now we're going to do our replacement. We have the same formula, and it says a replacement beam, same length of 3, but this time we know our K is 9.52. Same length is 3 inches wide, 7 inches deep. Okay, so that's 49 times 3 times 9.52, which is going to be 1399.44 pounds. So this, just by increasing this by 1 and decreasing this by 1/2 inch, increases our strength by almost 200 pounds. Okay? Because the depth being increased, that makes it a wider platform for it to hold it. And that 1/2 inch is not going to make that big of a difference. Okay, next. Remember we talked about inverse variation. When one goes up, the other goes down. Y is inversely proportional to x. You notice how that said y equals k times x? This one, because it's inverse, is y equals k divided by x. Okay, so this is a division problem when it's inverse. Okay, so example 4. Suppose that the speed limit is 65 miles per hour and a person, not you of course, your friend, likes to drive just a little over the speed limit. If your friend takes a trip and it takes him 1.5 hours going at 65 miles per hour, how much time will he save by going 70 miles per hour? Use the fact that time is inversely proportional to speed. Okay, so what we see here, remember we read the problem. Time is inversely proportional to speed. Okay, so we know that time in the original trip is 90 minutes. And we know our speed was 65 miles per hour. So we need to find our constant. So we're going to do 90 times 65, which is 5850. Okay, and that's our original. Okay, the next one is the new one. So time is inversely proportional to speed. This time, how much time will he save? So we're solving for time. We know our K is 5850 and our speed is 70. So here we just have a basic division problem and our time is 83.57 minutes. Okay, so it says how much will he save? The other trip took him 90 minutes. 90 minus 83.57 is 6.43 minutes is what he saved. Okay. All right, we got one last problem. As we stated in example 3, the strength of the beam is directly proportional to its width and the square of its depth. Okay. However, as you probably know from practical experience, the longer the beam is, the less weight it will support. That is, the strength of the beam varies inversely as its length. Okay, so we're going to combine our two things. Okay, so what this formula is going to become, the strength of the beam, we know that formula was KWD squared. But it varies inversely with the length. Okay, so that's how we get that. Suppose a wooden beam that is used to support lighting for an outdoor Shakespearean theater is 10 feet long, 3 inches wide, and 4 inches deep, and will support a load of 600 pounds. Okay, so we need to solve that one first to find our constant. Okay, so 600 pounds, we don't know our K, We know that our W is 3, our D is 4, and our length is 10. So that's 16 times 3 is 48. 48 divided by 10 is 4.8. So we divide and we get 125 for our K. Now we're ready to go. If the length of the beam is increased to 15 feet, okay, so let's go right here and we'll do A. So the length is increased to 15. How many pounds will the beam support? So this is S equals KWD squared L. So we know that the K, so they want to know how many pounds, so that's our strength. So this is 125 times the 3 times the 4 squared, because they didn't change those, but the length changed to 15. Okay, so we multiply these. So 16 times 3 is 48. Then you do 48 times 125. Divide that by 15. So the strength that it would support is 400 pounds. Okay? The longer the beam, the less weight it'll support. Why? Because when you stretch that out, the middle gets weak, right? And it'll break in the middle. All right, so let's look. If we want the 15-foot beam to have the same support weight of 600 pounds, okay, so we want how wide should the beam be to give us the same support? So that means that this time they want you to find a different width, okay? So the depth's going to be the same. This is going to be 15, and that's going to be 600. So 600 equals the 125. Then we have times W times 4 squared over 15. 16 times 125 is 2,000. If I divide 2,000 by 15, let's see what we get. Maybe I shouldn't do it that way. Maybe I move this over first, because that's going to give me a repeating decimal, and I don't want to round it too soon. Okay, so we'll do 600 times 15. That's 9,000. Divided by 2,000. That's going to be 4.5, and we're talking in terms of inches. Okay, the reason I didn't just divide that 2,000 by 15 is it gave me a decimal, and if I rounded it back here, then I'm constantly rounding. So I wanted to avoid that. So what I did is got the 15 out of the bottom and divided it. Okay, now let's say I did go with that 133. Let's say clear. Let's say I do that times 600. Oops. Actually, I need to put the 600 first, don't I? 600 divided by, it'd be 4.5. So either way would work. Okay, so that'd be 4.5 inches wide. Okay, and that's how that goes. If you have any questions, please feel free to reach out. Have a great day.